Hello, in this session we evaluate the oxides of carbon. Welcome. Carbon as an element occurs naturally as hydrocarbons, where it can be obtained by the method of cracking. When it exists naturally, it exists primarily as two allotropic forms, namely diamond and graphite. It could also exist in form of coke and other amorphous varieties. To enable us to understand more about the oxides of carbon, we can assume that when carbon is burnt in air, the quantity of air supplied will dictate whether it forms a monoxide or a dioxide. One, when carbon burns in excess oxygen, it forms the common carbon dioxide gas. When, however, it's burnt under limited supply of oxygen, it will form the uncommon carbon monoxide gas, which is poisonous. Now, what is carbon dioxide? Carbon dioxide is a colorless gas. It has no distinct color. It is odorless. It has no specific smell. It is denser than air, which means it can be collected by the method of downward delivery. Number 4, it is soluble in water, and when it dissolves in water, it forms the weak carbonic acid. It does not support combustion, so when a flame is brought into its contact, it extinguishes it. How do we test for carbon dioxide? We use lime water. When carbon dioxide is passed through lime water, it turns milky or cloudy, signifying the formation of a white precipitate in the form of calcium carbonate. With continued passage of carbon dioxide through lime water, the white precipitate disappears and appears as a clear solution, signifying the formation of calcium hydrogen carbonate. Therefore, the common test for carbon dioxide is lime water. How do we prepare carbon dioxide? To prepare carbon dioxide, we acidify metal carbonates. For example, when we have magnesium carbonate and hydrochloric acid, the hydrochloric acid will simply displace the carbonate and form carbon dioxide thereon. Now, the carbon dioxide formed will be propelled to the next chamber simply because the reaction happens in a flat body conical flask where the solutions remain as the remnants and the carbon dioxide proceeds to the next level and collected by the method of downward delivery simply because it is denser than air. How do we apply carbon dioxide? One, we use carbon dioxide as a refrigerant simply because it has a low melting point and simply because it sublimes. Now, when carbon dioxide is a gas, it can be condensed to solidify directly, and in the solid state, when it encounters only a slight change in temperature, it absorbs the heat around it and sublimes. In that process, it exerts a cooling effect, which makes it a suitable substance or agent for refrigeration. Two, we can use carbon dioxide to manufacture fire extinguishers simply because it does not support combustion and it is denser than air. So when it is used as fire extinguisher, it will always create a blanketing effect over the surface of a flame, cutting off the supply of oxygen and therefore extinguishing the flame. Number 3, we can use it to manufacture baking soda, which is mainly sodium hydrogen carbonate, which is a freezing agent that is used to manufacture some hot cakes. Next, we have soft drinks, which are in form of Coca-Cola and other fizzy drinks, in which carbon dioxide is condensed to act as a fumigant and also as a preservative. Now, we can also use carbon dioxide in the solvent process where it acts as an oxidizing agent in the large-scale manufacture of sodium carbonate, a substance that is used in the manufacture of glass. Next, we have carbon monoxide. Carbon monoxide as a gas is simply an incomplete form of the oxide of carbon, and therefore it is intermediate. However, it exists as a colorless gas, which is odorless, denser than air, insoluble in water, and neutral. And then it is combustible simply because it's deficient of oxygen, and when it is burnt in air, it changes into carbon dioxide. To test for the gas, we simply burn it over lime water, and then it will give us the same result as carbon dioxide, namely turning the lime water milky. Now, to prepare carbon monoxide, we need the adipic acid, which is dicarbon dihydride tetroxide. In this case, the adipic acid will be dehydrolyzed by Kong's sulfuric acid. Dehydrolyzing adipic acid will give us exclusively carbon dioxide and carbon monoxide. Now, the carbon monoxide and carbon dioxide forms alongside water. Therefore, we may need an intermediate chamber to absorb the excess water, and in the process, we also need an intermediate chamber to absorb the unrequired carbon dioxide gas. So we use an alkali such as sodium hydroxide to absorb the carbon dioxide to form sodium hydrogen carbonate, or potassium hydroxide to form potassium hydrogen carbonate, therefore leaving us exclusively with carbon monoxide as the precipitated gas. What are the applications of this gas? One, carbon monoxide is a reducing agent simply because it's deficient of oxygen, and when it encounters metal oxides, it will reduce them by capturing the oxygen thereon. Therefore, it's used in the industrial reduction of metals in the reduction process of metal extraction. Two, we can use it to manufacture water gas, which is simply a mixture of carbon monoxide and steam. Number three, we can use it to manufacture producer gas used in the industries, which is a mixture of carbon monoxide and nitrogen gas. And we find that the oxides of carbon, in spite of having these useful applications, they have a varied range of dangers. Namely, they are environmental pollutants. When carbon monoxide is burnt, it forms carbon dioxide. And when carbon dioxide descends into the atmosphere, it will meet the atmospheric water and form acid rain in the form of weak carbonic acid. Number two, carbon monoxide itself does not support inhalation or breathing. In this case, when carbon monoxide meets hemoglobin, it forms carboxyhemoglobin, which causes suffocation. Remember, in the absence of carbon monoxide, when you're inhaling, we normally take in oxygen to meet with hemoglobin, forming oxyhemoglobin. However, when carbon monoxide replaces oxygen, the substitute product will be carboxyhemoglobin, which inhibits the imbibing of oxygen and causes suffocation. Thank you. So this has been a description of the oxides of carbon, where we have said that the two main oxides of carbon are carbon monoxide, a rare gas, and carbon dioxide, a common gas. We have said that carbon dioxide is odorless,